Okay. So this is something that you might be actually tripping up on when you're doing this in your own testing, and that's the first step, which is realizing if you can do the problem or not. Is NP greater than or equal to 5? Is NQ greater than or equal to 5? And remember, P in this case is your prediction. So for those of you who have said something like 10% or 90%, you're going to have a problem there. I will still let you do the hypothesis test, and I don't want you to change your claim. The only difference will be is that, like, in the error section of your report, you'll just say, technically, I should have had a bigger sample to be able to do this. Okay. So verify you can do the problem. NP, NQ. So we're going to write down P and Q for this. A researcher claims that less than 40% of U.S. cell phone owners use their phone for online browsing. In a random sample of 100 adults, 31% say they use their phone for most of their online browsing. All right, so P here is 40%, which makes Q 60. So we're verifying we can do the problem. We're just going to take the smaller one, and it's what, 100 adults? So if we take 100 times 0.4, is that greater than or equal to 5? Yeah, that's 40, right? That's much, much bigger than 5. And we don't need to check out 60 because we know that that's also going to work, so we're fine there. All right, null and alternative. Instead of writing mu, you're going to write P. The researcher claims that less than 40%, so less than 40. Opposite of that is greater than or equal to 40. This was the claim. I've seen it written two ways, by the way. You could have it as 0.4 or you could write 40%, just as long as you write a percent after it. Sketch and determine critical values in rejection regions. Okay. So what kind of test is this? Left-tailed, right-tailed, two-tailed? Left-tailed. And alpha is 0.01. Remember, that's our willingness to have an error. So we need to look up on the Z chart, 0.01 on A16. Inside of the chart. Anyone have this one memorized by now? Negative 2.33. Then we're going to do our test statistic, which is p hat minus p over the square root of pq divided by n. So let's write out what these things are. We already know that P is 0.4 and Q was 0.6. Those are our claims, right? N was how many? Sample size? Yeah, how about P hat?
0.4, right?
Nope. P hat is your sample statistic, so it's exactly what happened in your study. So when they actually did the study, what number did they get? 0.31. So P is like the prediction with Q, and P hat is actually what happened. So if we find the test statistic, we're going to take 0.31 minus 0.4 over the square root of 0.4 times 0.6 divided by 100. All right, I got negative 1.84. You guys get the same thing? Okay. And that's a z-score. All right, so where does that fall here? Does it fall in the rejection region or does it fall in the null? Mm-hmm. Right about here, negative 1.84. So do we accept or reject the null if it falls in the null?
Accept.
Right, so we're going to accept the null. Does that mean that we accept the claim?
No.
No, it depends on which it is, right? And this time, if we accept the null, that means we reject the claim. So we're rejecting the claim that less than 40% of people use their cell phones for online browsing. It's almost exactly what you're going to do for your test today. All right, now, I know we've been using rejection regions a lot, but we still need to talk about p-values. So here's what we're going to do today. I'm going to show you a lot of different ways to do this. This was using rejection regions in a table. What we just did, writing that right next to the problem. That was rejection regions in a table. And for the next problem, we're going to use rejection regions and your calculator. Your homework, you're going to have to do 4 problems plus a little short bit, and you're going to have to do each one of these ways, so it's nice to label it this way. Huh? Are we going to have a test today? Oh, maybe I said hypothesis test? Okay. No, we do not have a test today. That'd be a pretty big shock to all of us, including me. All right, so a researcher claims that more than 30% of U.S. smartphone owners use their phone while watching television. So how should I write that one? Researcher says that more than 30% use their phone while watching television.
Greater than or equal to, or greater than 30%.
Right, P is greater than 0.3, that's the claim. Opposite is P is less than or equal to 0.3. Okay, so I'm going to write down really quick a lot of stuff that we need to put in our calculator. Then we're going to use our calculator to solve this for us. What's P hat and N in this problem?